Hello, good afternoon. My name is Xiaoyi. I come from the School of Agriculture and Science of the University of Dublin. And today the topic is effects of manure application on grassland productivity, nitrous oxide emissions, and soil carbon storage of monitoring study using DNDC. And today the result is very preliminary, so not as much as the previous studies. So grasslands are a vital component of agriculture systems, and they not only support livestock production, but also play an important role in soil carbon sequestration, mitigating climate change. And to maximize these benefits, different sustainable managements are used. For example, the application of organic fertilizers such as the cow manures and pig manures. And these manures are not only waste products, they are very important for to improve the soil fertility and also increase the soil carbon levels. And to better understand and optimize these different systems, we used the model DNDC model. The full name is denitrification decomposition model, and it has the potential to simulate the impact of manures on soil carbon and crop productivity. So this is the surface of DNDC model. As you can see, the input include climate information, soil information, and crop information. So you just simply put the information inside. And then what's the purpose of this model? The purpose is to simulate the biogeochemical cycles in soil, such as carbon cycling, like the decomposition and sequestration processes, or the nitrogen cycling, like the denitrification, nitrification, and ammonia volatilization. It will also simulate the give you information about the greenhouse gas emissions, like CO2, N2O, and the methane soils. And the objectives of our study include first to calibrate and evaluate the model using the measured data. And then we will evaluate the effect of long-term manure application. Like now, we simulate until 2046 on grassland productivity. And then third, we will assess the impact of manure, this long-term manure application on soil carbon storage. So this is our study site. It's a place called Hillsborough in Northern Ireland, and it's brand new grassland. And it has been established for 55 years, and clay loam soil and 3 cuts a year. And there are 8 treatments in this field. We have control and NPK, inorganic fertilizer, and different rate of manures, different like low rate of cow manure, medium rate of cow manure, and high rates, and then low rate of pig manure, and medium rate of pig manure, and high rate of pig manure. And as you can see that this different rate is based on different volume. Like low rate is 50 cubic meter, and medium rate is 100 cubic meter. So as you can guess that if we apply this different rate in field, like based on this different volume, then we cannot guarantee that the nitrogen concentration are same, totally exact same every year. So the reality is the N rates or C rate is actually different in different years. We only control the volume. Yeah, and about the nitrogen application rate, it's about, so for the low rate, it's about 200, medium rate is about 300, and high rate is about 600. Yeah, then, so first we simulate soil temperature. It's 0 to 10 centigram. Oh, this figure is 0 to 5 centigram. So these 8 figures are 8 treatments. The blue lines are simulation, and then the red lines are measure data. And there are 28 different measurements in 1 year. Well, this is a figure. And for to judge whether the model performance good or not, we use, for example, RMSE or NRMSE. And this is as you can see, this is the equation. And if so, according to articles, people say that if this NR minus E, if they are lower than 10, we can say it's excellent, and or 10 to 20 good, or 20 to 30 fair, or so which means the smaller the number is, the better performance it is. Then we also use EF, it's called the Nash receptive model efficiency. And for these EF values, if it's closer to 1, then it's better. So just now we have the figures of soil temperature, and this is a result of the RMSE or EF. So the conclusion is it has good performance. Then we simulate this N2O in 1 year in 2016. The blue line is, there are 8 figures in this slide, which is 8 treatments. So the blue line is simulation, red line is the measurement. As you can see, it doesn't simulate very good. Especially there, the second peak, you can see always a blue peak. That is after one time of manure application. So the model always simulates there is a very high peak into all emission. However, in reality, we didn't. At least there's a from the data of technician, there is no very high peak into all emission. So whether we change the input data, then it may behave better. But some reference they did change the parameter. But our choice is we don't change the parameter because we don't want to like satisfy the figure to make them fit and to change the parameter. So this is just without changing the parameter. And then this is poor performance, unfortunately. So always there is a high levels in simulation. And maybe the reason could be that the measurement always understimulates the complete denitrification. Yeah, or maybe in reality, the measurement will fail to capture all emissions. So the performance of N2O is not good, so we cannot use it to simulate N2O in the future. And but we still have SOC carbon, and we simulate SOC in different years, like 2012, 2013, 2016. The red is measurement, the blue is simulation. Yeah, so as you can see, the red line, the red column is always a little bit higher. So the measurement is our, the simulation, the blue simulation is always a little bit lower. But according to the data, it's still good performance. Then we simulate the yield. Yield actually behaves better. So the red column is, this is different column is different years, like from 2010 to 2013 and 2016. And then the red line is merit, blue line is simulation. Yeah, so it looks better now. And it's also good performance. So then we measured those different things. Then we want to simulate what's in the future, what's the impact of long-term utilization. So until now, we haven't applied different like weather patterns or different management practices. So these figures are just based on the current practices and current like weather patterns. So as you can see, there is no inhibit or negative effect of all treatments. So they are all increased slightly, even those very high application rates of pig manure, cattle manure, they are as high as, for example, the cattle manure is 640 kgN per hectare. So it's still good. It doesn't have some bad effects. And and they all increase slightly, and their increase rate is all between 7% to 8%. Yeah. Then this is as I say. So the yield, all of them, they behave very good. And then we see the yield. Then we see the SOC, because we want to, because SOC, you know, it's good for, this carbon sequestration is good for the, it's good for the, yeah, it's for the, good for the environment. So this cattle high, it behaves fast, and it just, this SOC just increase slowly. So we can see that all of them will increase except the CT, except the purple one. It's CT is a control. And the highest levels is CH, which is cattle high, and cattle medium, and then peak high. Yeah. And if so, why this CT? Why this control? Each SOC just slightly decrease. The reason is that natural decomposition of organic matter is already larger than the input of plant residues and the root residues. So the result is SOC just decreasing. But for other manure application sites, all the soil carbon just increase. So until now, this is our very preliminary results. And our future work includes to apply these different patterns or practices into this model. Since now we have simulated some things very good. And also we may analyze the soil microorganisms in these different soils. Because until now we can see that they already show this different carbon sequestration rate in different treatments. And so conclusion is this model is good for just the yield and soil temperature simulation, however poor in these landfill emissions. And in the next 20 years, the yield is expected to increase slightly with peak high and cut high, showing the highest yield. And SOC content is projected to still increase for all treatments, except its control in the top 10 centimeter. And in top 10 centimeter, the highest SOC level is predicted for cattle high, cattle middle, and peak high treatment, but lowest for the control treatments. Yes, thank you, our technician Laura, and this Agri-Food and Bioscience Institute, and this is funded by the True Soil Project. Yeah, thank you.